All right. So, welcome everybody to this presentation on the revisions of our Highline system standard. This is a document we created in 2018, 2019. Okay, nice, hello. And I'm happy that we can show the revisions today and discuss them. I'm gonna try to keep my presentation as short as I can. I'm not known for being good at that, but let's see how it works this time. Can everybody see the agenda here? Yeah, that's good. So this is what we're gonna be doing today. I'm quickly gonna give a short intro, then I wanna talk about what we changed in the standard. Mostly in the scope and then some specific revision. And then I want to basically try to answer your questions together with the people that are here from the Safety Commission and all the experienced people. So we have quite a bunch of manufacturers in the chat. We have independent people. We have testing laboratories. So it's a wide range of people that are here today. My aim is that we end at about 8 o'clock at the latest, and then close the meeting and just have the manufacturers and maybe the test labs with us here to discuss specific questions, not necessarily only on the Highline standard, but on the other standards as well. So I'm just going to get into it. Very generally, this is the organizational structure of the ISA, and we are today within this section, which is called the Safety Commission. That's the commission that works on the standards. So Safety Commission, just to give you a broad overview, this group like this from the main ISA. So the main ISA has 20 national federation members, about 70 regional members, and approximately 3,000 individual slackliners, which are part directly or indirectly of the ISA. The Safety Commission is one of these 4 commissions we have. So we have about 10, we have 10 Safety Commission board members, short we call them SafeCom. Then we have more than 10 slackline gear manufacturers, which are ISA partners. And if you want to know more about the Safety Commission, you can always put in that link /safety or write directly to safety@slacklineinternational.org. And I don't want to go through this in detail, but just to let you know that the Safety Commission has its own charter. So this is like their own statutes, the legal paper that we created for the Safety Commission, and highlighted here in bold letters are the aims of the Safety Commission in general. So one of the first aims, besides assisting member federations, is to develop standards, analyze the market, and then also keep these standards up to date in the future. As I said, I'm not going to go through this in detail. You can always have a look online. This is all public data. So these are the 10 SafeCom officials, so people that got elected into the Safety Commission. 2 pictures are missing here, but you get the picture. So these are all independent experts. They're not affiliated to any slackline company, which is important for Safety Commission. And maybe you see that I'm not on this list. It's because I am not directly part of the Safety Commission, but I'm in the ISA Executive Board and work very closely with this group of people on the standards. The Safety Commission has partners. Currently, we have 5 gear manufacturers that are partners and have ISA certified gear. So these are so-called ISA safety label holders or partners. And we have 2 manufacturers, these at the bottom, Slacklifing Company from India and Spider Slacklines, which are currently in the process of getting their gear certified. So in total, 7 manufacturers which have ISA certified gear. We have 2 independent test laboratories, Siebert Consulting and Block Material. Siebert is from Austria and Block from Germany. once these independent labs test the gear, they give us an and we basically approve this piece of gear, and the gear manufacturers get such a certificate from us. We also have Safecom partners which not yet have certified gear. These are these four, and we hope to get them on page with certified gear in the future as well. So here, a quick overview of the standards that we so far have published. The one we're going to be talking about today is ISA 21 Highline System. And this is basically a full system standard with full of definitions. I will go into it afterwards in more detail. And this is a bit different from the other Highline gear standards, which are mostly testing protocols for these pieces of equipment that you see listed here. So these are the standards the testing laboratories have to work with and then have to follow in order to certify the gear of a manufacturer. So with the Highline system standard, there's no like tests involved, like full system tests. So we have done those in the past for scientific purposes, but basically this standard we talk about today is not a protocol that describes how to test the Highline system, but it's about how Highline systems are defined. Okay. And if you want to get an overview of the gear that we already have certified or approved, you can go onto this website or the other website you saw before, /safety. You will find the link there, and you will get into this database, and you can look through the certificates that we've issued so far, 26 certificates issued by manufacturers. Okay. On the other hand, we also have this. We have a gear warning database with about 78 entries. And we, in this database, we discriminate between notices, warnings, and also check that out if you have not seen that before. So you can go through this list and find, sort by product type and find notices, warnings, and recalls on these different types of gear. Definitely something that is useful to go through every once in a while and check. Okay. Now I want to specifically get into the Highline system standard and discuss it a bit and show the revisions we made. Okay, I want to start with the scope because we have worked on this. Basically, the scope of a standard lays out why we do this standard, what is it about, what are the aims. And so the first aim I already talked about, it's about defining components, dimensions, and forces. As you all know, our sport in a historical fashion has grown, as has the terminology for highlines. And lots of the terminology we use is very informal terminology. So if you go to engineers or static engineers or building engineers and show them or talk about our wording, they will usually not understand it. So one of the ideas behind the standard is to get like a general definition of wording. Sorry, it's a bit annoying. You have to switch back and forth and accept people here. To get like a general understanding of what we are actually talking about. So this is one big goal of this standard, to define components, dimensions, and forces within the Highline system. The second goal, and this is something we added now to the standard, but it was already actually our idea in the first version. It was not just added to the scope, is to enable if Highline systems fulfill this standard, that these Highline systems can be used in workplace situations. So the only thing, and I'm going to come to this, we don't have in this standard yet, but we want to do it in the future, is talk about maintenance and checklists and so on. So that's why this add-on is here as well. So workplace situations, if maintenance checklists are utilized. So such workplace situations can be, for example, shows, courses, competitions, and festivals. Obviously, it can be also more than that, and basically any type of situation where you have some sort of contract and basically receive money for setting up and being on a Highline. So that's where this standard should be useful in the future, we believe. So this is a big discrimination towards recreational highlining. I will come back to that afterwards as well. Then another scope we added, which we think is important because we will talk a lot about forces. And so one idea from past measurements that we have done is that the maximum forces we would like to see in a main line, which we refer to as the working load of our Highline system, is should not exceed 12 kilonewton. So in other words, if a Highline is rigged and you would measure more than 12 kilonewton from somebody leash falling in the middle, this would, in our understanding, mean that you have done something wrong in rigging that Highline. Okay, so this is basically the baseline of what we are thinking of like a safe and secure Highline system. So 12 kilonewton working load. So that's the peak force in a leash fall. And then 3 more scopes we added, and this is something we can maybe discuss afterwards because these are also new and maybe the wording needs to be adapted a little bit. But basically, as you all know, we use lifting equipment standardized after the machinery directive specifically now in the EU. So this means shackles and slings, industrial round slings, and these specifically are not made for human load. Okay, so we use them. This is a standard procedure. It's has proven to be very safe for us. Especially the slings are very abrasion resistant, and the shackles have proven like the real thing for us compared like to carabiners. So with this standard, what we want to do is we want to allow this lifting equipment in the main load path of the Highline. And I think one important add-on that we have to, or like one constraint, which is very important because basically this is more or less not legal, talking straightforward. We have to have some secondary anchoring material equipped as well in our Highline system. So if, like talking concretely, if we use an industrial round sling, there always has to be a secondary system that backs this round sling up. Okay, so this is how we can allow lifting equipment in the main load path of a Highline. Good, this is number 1. Number 2, same applies for climbing and mountaineering equipment, which you know we also use. I think one of the most prominent examples would maybe be the use of quick links or maillons connecting two main lines in a Highline system. So also for this case, this standard would allow the use of this climbing and mountaineering equipment, so standardized after UAA or EN standards, also only if this is not a single point of failure. So again, a maillon connecting two main lines, this would mean that there is a backup of some kind that is in place. So that's how we can kind of work around this. And the third thing, which is also something we talked a lot about also in the past, There is something called ropes courses. These yeah, recreational and sports ropes courses that you can find in almost every country around the world. And these are in Europe. There is a standard for that, EN 15560 67, and basically we make an indirect reference to temporary installations in this standard. This is a bit a special thing. In that standard, it actually specifies that temporary installations are excluded. So we reference this standard to have a reference to an existing EN standard, but on the other hand, because most Highline systems are rigged less than 7 days, they actually don't fall within that standard anymore. So this is excluded. So this is just a little bit, I'd say almost a little bit of a trick we do in order to reference to a current standard. And I think we can remove this once we have maintenance checklists in place in our standard. So I'm assuming in the next revision of this standard, we can remove this 1.3. Okay, if you have questions, just write them down and I'll try to answer them in the end. So now coming to what is new in ISA 21. So things we have added since 2019, so in the past 4 years. There's been quite a development in what we call intermittent connections, IC. And I'm gonna go and show you in a second what that is. Basically, intermittent connections are anything connecting a main line and a main line and a backup, or a backup and a backup. And we have differentiated 4 different types of intermittent connections, and I'm just gonna show these to you quickly. So number 1, we call joining points. So this would be a soon, main, and backup connections. Some people refer to this as type X. So you have like one soon connection in the middle of a Highline. That would be a typical soon joining point. And another way, another joining point would be a main, or backup connection. You can see this now with the current freestyle Highline setups, where pieces of webbing are soon into the middle of the Highline. So these two we refer to as joining points. Then we have what we call splitting points. So in such splitting points, most of you will recognize these types of splitting points. So basically the main line is split, and you have in this case 2 connectors and then 4 loops that come together. These connectors could be quick links or soft shackles or other things. And another type of splitting point would be a main or a backup connection, where you have one maillon or one soft shackle, and also knots or girth hitches. Think of like backup extenders are also a type of splitting point. So for the knots and girth hitches, it's important that we state, so we would like to see these in main load paths, so only in backups. Then further intermittent connections, so-called fractioning points. And the difference between the splitting points is that in these cases, the main line is continuous. So you have a continuous main line, and you have what a company refers to as fractio. So you have, in this case, 2 backups going into one connector, and you have these 2 soon connections towards the middle connecting this one connector. Then there is another type, dura la vida. Most of you know that as well. It's also what we would refer to as a fractioning point, and also the connection of 2 T loops would also be a sort of fractioning point. Then the 4th type is what we call backup line support points. So these could be either stitched or capes or any other sort of connection. Basically showing that these can rip in case of a mainline failure. So these are not meant to hold the whole force. That's the big difference to what we had before as a joining point. Okay, so these are the intermittent connections we identified and included in the new standard. By the way, for those who want to read it in more detail, I also put the link to the standard in the chat. That's the current version. In yellow, you can see all the changes, and you are all in comments mode, so you are allowed to comment questions or things onto the standard right now, and we try to answer those questions afterwards. So now what is important? Why did we discriminate these different intermittent connections? Basically because we think there are different strength requirements for such connections. So the most obvious one, which we can talk about first, is mainline. So there, basically, we are talking about soon loops connecting in whatever way. And already for soon loops, we have this what we call the 80% rule in our standard. So soon loops, here shown on the right, mainline soon loops, have to fulfill 80% of what the webbing holds in basically a test in our ISA 41 webbing test. So for those who have never seen this, on the left we have the 4 types of webbing strength classes that we discriminate. Be careful, these are not the types you maybe know. So type C has nothing to do with selectivities. Type C, this is a strength class type C, something different. So important to know is that basically we have these 4 different types. When a webbing is tested with an independent laboratory, the webbing will fall in one of those 4 types. So the weakest type we accept right now is 22 kilonewton minimum breaking strength. And for the mainline zone loop, this webbing has to hold at least 18 kilonewton in the zone loop. And this is obviously because this is the strength of the zone loop. This will also be the strength of the zone loop towards the intermittent connection. So not only towards the anchor, but also towards the intermittent connection. Something that I maybe have to specify on the lower right corner, you can see that type B and type C, not every webbing can be standardized after type B and type C. So only polyester and polyamide can fall into type B, and only polyamide can fall into type C. This means that like any sort of what we usually refer to as high-tech material, but in the standard we call it low-stretch material. All the low-stretch materials have to have a minimum of 30 kilonewton MBS. So there's no, let's say, like Dyneema webbing that we would accept in our standard under 30 kilonewton, and therefore the mainline zone loop of that would have to be 24 kilonewton. So that's for mainline connections. And then there is a second type of connection, the mainline backup or backup connection. We put them both in the same strength requirement categories, and you can see these are a bit lower. So basically 50%, not 80% anymore. So now we are talking about the zone connections on mainline, the strength of these depending on the strength class of the webbing. So in other words, the weakest webbing, let's take the weakest webbing, which can only be a nylon polyamide webbing. As we saw before, it has to have 22 kilonewton minimum breaking strength. And let's take, I don't know, a T-loop or a Dura La Vida or something like that, has to hold at least 11 kilonewton if we pull it in our test. Okay, that's how you have to read this diagram. And then you can also see, and this is also a bit special, that basically in this 50% rule, all the high-tech webbings or ultra-low stretch webbings are excluded. So they have to follow a separate scheme of strength. I'm showing that on the next page. So for ultra-low stretch webbings, the minimum requirement of such a mainline backup or backup connection is 24 kilonewtons. So it's more than what we would want with a polyester and polyamide webbing, because forces with these ultra low stretch webbings always are higher. That's the reason. Okay, so sorry for this complexity. I tried to break it down as easy as I could, but that's one of the big major changes in our new standard, including those what we call intermittent connections and strength requirements for these connections. With that also came the question not only of the connections, so of the zone connections, but also of the connectors. So now I'm talking about the soft shackles and quick links and so on. And here on the right, you can see that the connectors also now have a minimum strength requirement. For the main line, they have to be 32 kilonewton. For a connection to the backup or backup, they can be 24 kilonewton. And then also in terms of fractioning points, here the requirements are 24 kilonewton. For the backup line support points, we have no strength requirements. Maybe in the future, but we don't have enough knowledge about this yet. Also something very hard to measure, actually. Okay, so this is now important. You can imagine a manufacturer wants to standardize their webbing. They send this to the testing laboratory. The testing laboratory not only measures the strength of the webbing, the manufacturer can also ask for measuring the strength of the Zoom loops and of the intermittent connection type. So this is something that is now possible. Okay, so this was the big topic of intermittent connections and connectors. I hope I could explain this a bit. If not, I will come back to it in the questions. Then some other things we added. The mentioning of optional signalization of a highline. This was not in there so far. Basically, materials that signal that the highline occupies an airspace. So this could be anchor signalization, as you see on the left, these orange balls we use in Switzerland. This could be infrared light for using the highline overnight, which is required in most countries, in the Alps at least. Or we have parallel ropes with wind flags that need to be rigged at a certain height or length of the highline, depending on the regulations of a specific country. So this, as an optional thing, we added to the standard. Then also we just added the mention of so-called helping lines. So here an example from GGBY. Basically, in this case, it's basically a second highline rigged above the existing highline, and allows usually beginners to make their first steps on a highline. They obviously require separate anchors, which should not abrade or become tangled in with the main line, or the leash should not become tangled in with mainline and backup line. So this is just a mention of this type of new helping line. Then also something we didn't have in the standard before is the mention of backup line extenders. Most of you have seen those before. Basically, short pieces of webbing, could also be an EMO or something else. And the strength requirements for these are the same as for backup lines. Also, what is new, we mention knots. We have not mentioned knots so far, and we use this very general terminology. So knots in webbing should never be used in the main load path. They should only be used under extreme caution and only for backup webbings, webbing locker tie-offs, and anchor tiebacks. So this is how we mention knots in our standard, which we have not mentioned so far. Something else we added, clearance point, clearance area, and fall zone. These are just basically three nodes in the graphic I will show in 1 second. Here. So this is the general overview graphic you have in the standard, and all the things here circled in yellow are things we added. So I'm going to go through them quickly. All the threes here are the three types of intermittent connections. So mainline, mainline backup, and backup backup connections. Then we have the signalization, which is number 17, and the three things I just mentioned, the clearance point A, so basically the point where the Highline systems leaves the edge. Then we have point B being the clearance area surrounding the Highline. This basically came out of the accident we had in the Netherlands where the Highline basically hit the top of a building and failed in the middle. So you need a certain clearance area, not defined in meters or anything, but just defined as an area that needs to be free of obstruction. And then the point C, which is basically the no-fall zone, the zone in which the highliner, if he falls or she falls, hits surface or ground. Okay. Good. So that's that. And now I just want to show quickly 3-4 pictures before we can go into the questions on what we consider not to be an ISA 21 Highline system. So one classic example is the use of non-redundant anchors. So on the left side here, you see um, uh, basically one industrial sling. I'm assuming this is one industrial sling on a sliding X. And the webbing is just laying around there. It's maybe tied off a little bit. I don't know. I can't really see it. But such single span sets with a sliding X or single span sets extensions over the edge also, this would not be considered an ISA 21 Highline system. So you have to have a backup of that industrial sling, which is in this case in a sliding X, in order to make it an ISA 21 Highline system. Some people usually say, yeah, but why do you back up industrial sling which holds, I don't know, 12 or 14 tons with a single rope? And the answer is very simple, because if we wouldn't have done that in the past, we would have had several deaths. So abrasion is a big one, also with super heavy-duty industrial slings, usually in combination with wind or some faulty rigging, sharp edges. Also, these industrial slings are under tension, they're more or less well padded, as in this case on the left here. So single span sets with a sliding X, and also span sets as extensions over the edge without a backup. It can just be a rope backup. That's basically enough, but it needs to have some sort of backup. So that's number one. On the right side, you see a picture of a sliding X made of rope, and then I think backups with Dyneema, whoopies or something like that. So this would be considered an ISA 21 Highline system with basically a backup anchor in place. Another thing, the use of carabiners in the main load path. So be it between the web lock and the anchor, or the soon loop and the anchor, is something we would not consider an ISA 21 Highline system. We have quite a few failed carabiners, even heavy duty ones, so we don't want to see these carabiners in the main load path. Even I would extend that to the connection between the anchor and the attachment points. So what you see here on the picture, even though I'm totally aware these are super heavy duty carabiners and they're probably not going to fail, but for workplace situations, I would definitely connect this with Mayons and not with carabiners. Even the heavy duty carabiners, you can really see how they are working and how they are basically not being pulled very nicely with wide span sets and so on. So for workplace situations, we recommend to use quick links in such a case, or go into the bolt directly with a rope, for example. Maybe also to mention, for backups, this is a bit different, because for backups we don't have this constant load on the system. It's basically a one-time shock loading, and there we see carabiners as useful. Not every type of carabiner, obviously, but this is really up to the judgment of the rigger to install the right carabiner at the right place for backups. This is not something we say would exclude this system to be Highline system ISA 21. Okay, and then probably because this question will come anyway, and we will have to talk about it. So, what is if you don't follow this ISA 21 Highline system standard, right? So I think the first important question you need to ask, is this a recreational Highline setting? Are you going out just with friends? Or is this really workplace highlining? So shows, competitions, you're getting money for that, or such a thing. So that's the first thing. If you are in this workplace situation, I highly recommend you follow ISA 21 for recreational highlining. I also recommend you follow, but if you don't follow, there's always, other optional things you can do, which are also good. And then at the end of the day, it depends on two things. It depends on what specifically happens. So let's say a single sling broke, a single sling, industrial round sling broke, and this led to the failure of this highline, or a carabiner in the main load path failed. Then even in a recreational highline setting, probably the person like cross-checking this specific case with our highline standard would find out that this was not an adequate, like a good highline rig, and this means not so good for you. So it really depends on what happened, and it also depends obviously on your national law and who is in charge of your case. So for let's say I can give you an example for Switzerland. In case of a highline injury with a case of death or heavy injury, there is a group activated which deals with mountaineering accidents. Fortunately, we are part of this group now with Swiss Slackline, Swiss Highline. So they basically define an expert, and this expert has to write a piece of paper that will then be used in front of the judge. So this expert will have to explain to the court how this accident could happen and how it relates to the current standards, which in this case would be ISA 21. So this is maybe just some mentioning on what can happen if you don't follow this standard. Okay, and then last slide, what's next? What is still missing? We think defining and including maintenance intervals and checklists, that's still missing in the standard. And then also including the definition of rescue gear, components, and forces is also still missing. So these are two things for the next version we want to do.